Everyone, welcome to our session, Monitoring Lambda and Serverless Applications. My name is Andrew. I'm from New Relic. This is Alberto.
I'm Alberto, New Relic.
Sean from Capital One.
So before we get started, a little bit about New Relic.
Ever wonder how a simple shell script can take down your entire system?
And by simple, we're talking like 7 lines here. Routine stuff.
Stuff that shouldn't be causing outages in the middle of the system on a holiday weekend. We were scrambling.
We had no time,
No solution.
no idea what we were going to do.
It's not easy out there. Never was. Every day expectations increase. There's more complexity, more risk, and it's hard to move fast when you don't know what's happening. But what if you have the data you need to steer you in the right direction? So whether you're hunting down a bug or migrating to the cloud, you have the confidence to do it faster. That's what you get with New Relic. It's the data you need, delivered as a service. It's instrumentation for everything, in your data center and in the cloud. Every connection and customer interaction, monitored in real time. Only our cloud-based platform gives you the insights you need to innovate faster. You can find and fix errors quickly, know the impact of every change. With all your teams on the same page. Because when you know what's happening now, you'll be ready for what's next.
It's a very nice TV commercial. All right, so with that, let's get started. To go through a quick agenda about what we're going to talk about, we're going to talk about basically the new challenge that's introduced by serverless, specifically Lambda and managed services. Finding, monitoring blind spots, like how does the evolution of workloads in the cloud using serverless lead to blind spots that traditional monitoring tools might not solve for. The type of data that we're going to gather that we think is really important for you to gather and synthesize. A good session on Capital One lessons learned as they adopted Lambda specifically, and then a really quick what's next. So with that, I'll hand it over to Alberto, who's going to talk about serverless workloads.
Good. Thank you, Andrew. So yeah, we live in a world today that has gone in a little bit more than a decade from stamping CDs and delivering updates to our customers, basically deliver code in production multiple times a day. So what we are seeing across the board is that today our stakeholders are basically demanding us to move at an incredible speed. And the industry has evolved a lot, and we have a lot to thank to AWS to remove the friction by many orders of magnitude from like getting us away from the physical layer and getting us on top of instruction layers such as serverless that can help us develop code much, much, much faster. But even though these technologies are awesome, and I think it's never been a better time to be a software developer, I think there's a flip side of this. So it's great, it's awesome, it's never been a better time, but there's a lot of hassle, and there's a lot of problems on monitoring those dynamic, highly scalable, distributed systems that we build. So today we're going to talk a little bit about how does that play in the serverless world. So while this room won't be full today if there was not, so serverless wasn't perceived as the next new evolution that the cloud has to offer and the next new abstraction layer that the cloud has to offer. It's been amazing what you can do, like with a little collection of functions and some AWS services. You can put value really, really fast in the hands of the customer. And I ask that continuously to our customers. So why do you use serverless? Why you guys are in a strategy to move to serverless? And I get a lot of answers like, because it's cool, because it's a good challenge, it's a nice challenge. But there's some like consistent answers that I get. So I get because I don't want to manage servers, I don't want to do that anymore. Because I didn't expect my teams to be operations experts that can scale an infrastructure in a matter of minutes. Because I want my teams to be focused on delivering value and focus on code instead of having to worry about versioning and stuff like that and managing VMs. and right scaling them. And I also start getting an answer which is really interesting to me. And it's because I can track how much every single interaction with my software costs. And serverless just works. So it just works. I captured this sentence, this quote the other day. I'm going to read it. People still haven't figured out a great use case for serverless beyond batch jobs and cron jobs. It's a sentence from an analyst. It's a quote from an analyst. So I would say that might have been true when Lambda was released in 14. But I think we have figured out a lot of use cases for serverless. A lot. I mean, much more than analysts think, I guess. But I think that's not the challenge. So the number of use cases that we can build on top of serverless is not the challenge. I think the challenge is how to monitor that stuff that we can build on top of serverless. We'll see later in some examples what are the challenges, but I think the challenge is not getting the use cases. The challenge is actually like monitoring those use cases. I want to just show some data to exemplify the level of adoption we're seeing from serverless lately. This is data that I've been collecting for the last year, but we're data nerds at New Relic, so I just captured the ones that I think are more interesting to share with the audience today. And the first one I want to talk about is the growth, the staggering growth that we see in terms of invocations to Lambdas. So in the last 6 months, we've seen a growth of almost 400% in invocations for Lambdas. Just in number of functions, we're seeing that the number of functions more than double every quarter. And in terms of execution time, we are now at 88% of Lambdas running below 5 seconds. Just for your information, like this same value 6 months back was 79%. So what we get with that? Basically what we get is that people are using more Lambda, invoking more Lambdas. People are generating more Lambdas. So we are generating more Lambdas, we're invoking them more, and they're running faster. So that looks to me, I don't know to that analyst, but that looks to me like people have figured out how to build microservices with serverless and how to get them together to produce applications. There's another kind of data point that I want to share. It's basically the scripting languages and runtimes rule the serverless environment. So Node makes like 44%, and Python makes 37%. By the way, that's data collected from the New Relic platform. It's data that we see across all entire 17 plus 1,000 customers. But there's another piece of data I want to share with you today. And that one's been particularly moving us. 89% of our customers in an internal survey that we sent to customers that we saw that were using Lambda intensively. We sent that survey asking what was the level of frustration they were getting while trying to monitor serverless environments. 89% of them responded they were either frustrated, very frustrated, or extremely frustrated. So that's a lot of frustration to deal with, right? So, and that comes from September last year. So there's been a lot of people frustrated for a long time. So why so frustrating? Well, I'm just going to exemplify how frustrating can get a serverless application. So in serverless, you can build an API literally in minutes. So what I try to do here to play a little bit is I'm just going to get a post request. I'm going to process this request. I'm going to store the result of this request, right? So in this example, I'm going to do that with API Gateway, Lambda to process the request, and Dynamo to store it. And how will I monitor that? Well, in this environment, everything looks like pretty synchronous. So, but just monitoring the Lambda and Dynamo CloudWatch metrics, and a few trips to logs, should be fine to me to be able to monitor that application pretty well. But we all know that this thing can get complicated pretty quickly. So what if we add like an easy stream there, and how the monitor will be then? Well, with Kinesis, we're introducing an asynchronous piece to that environment. So that means I need to publish, and then someone will consume that record, right? So when we need to consume that record, we need to break it down into another Lambda that will consume from that, will be subscribed to this stream, and then it will process the stream, aggregate data, and store into S3. So we're basically doing the same thing, but the monitoring challenges that we are adding at this point in time are pretty big. So, and while the visibility into every single invocation is crucial to understand here, what really matters is how the conjunction of the services are working in orchestration. So it's no longer, the first Lambda execution no longer defines success. What defines success is how everything works in combination. So we think that this thing can get more and more and more complicated from here. So in order to understand what data we should gather as our applications grow in the serverless environment, I'm going to hand it over to Andrew.
Thanks, Alberto. So obviously, as we evolve our systems, there's a lot of data being produced. So I was having a conversation today with somebody, and as we think about serverless applications, it's really moving from this construct of an app that you install on a box somewhere to this composite application that uses lots and lots of micro components, almost nano services themselves. So it could be a Lambda function, it could be an application based on Kubernetes, it could be a bunch of managed services that exist at AWS. I mean, there are managed services at AWS that do entire groups of work for you, like transcoding a video, that you don't have to maintain any infrastructure to do anymore, and they're all part of this larger workload. And they're all generating data. So as you think about monitoring your serverless applications, New Relic has always been kind of thinking about this breadth and depth approach. New Relic was founded on this application performance monitoring foundation that really was about introducing depth into understanding the performance of an application. And we think that the same paradigm of depth, where you're doing computational activities, and breadth so that you can understand the scope across your entire workload is equally important. So, I mean, what data should we collect? Hey, we think metrics are pretty important. So aggregates provide a signal, right? They tell you when you look at a dashboard or when you get paged that, hey, there's something going on, and it is anomalous, or it is something I don't expect. The dashboard can provide a visual indicator. The number itself can provide an alert. If you look at a sudden spike in invocations that was unexpected and you just deployed a function, did you accidentally create a recursive loop where you are accidentally calling the same Lambda over and over? It's been done before by lots of people. I'm sure some in this room. Or all of a sudden, is your API just suddenly popular, or did you make a change somewhere in your system that's actually creating a lot more traffic than you anticipated? Error spikes are much the same, right? What sort of errors am I seeing? Are they expected errors? How are they classified? And duration is obviously critically important too. Stacking the components of your functions, even with inside the executions themselves, to understand if there's a component that is actually potentially leading to downstream effects. You're calling S3, and it's taking longer than you expect, and that's leading to processing delays in your data stream processor. But not all metrics are like super created equal. If you look at even some of the standard metrics that come out of the Lambda platform as an example, you see stuff like memory usage, and that one's a bit of a head scratcher because memory isn't really like memory in the Lambda world isn't the same as memory in the physical server world, right? You don't have stuff perpetually running there, so even if you have like a short-term memory leak, the past is sort of erased for you, and you get to try again. There are exceptions, right? There are instances where you could stack up a bunch of properties that essentially exist in the container forever, and you could just get out-of-memory exceptions, but then you would get a cold start in a new container and try again. What I'm trying to say is there are certain metrics that can lie to you. You can say something like, oh, I'm using a ton of memory, but I never get an out-of-memory exception, and the processing time for my function is totally within the bounds of what I care about. And so like that in itself isn't terribly alarming. There's also a bunch of talk about like concurrent execution. So concurrent executions on a particular Lambda also aren't terribly helpful. So Lambda manages your throttle limits at the account level. If all of a sudden Alberto decides that he's going to spin up Alberto's Lambda load test and use all concurrent executions of Lambdas, and my little API that gets called once every couple seconds suddenly gets throttled, I'm going to be pretty unhappy because my SLA is shot after a few seconds, but Alberto might not even notice. So you know, we get metric data and we say, hey, something's going on, or I notice that something is amiss, I want to dive deeper. So we dive deeper in a couple of ways, and one of the first ways that we do it is through tracing. So New Relic has a feature called distributed tracing. It's pretty similar to AWS X-Ray, but this provides basically context across a chained set of requests. So we're really big believers in distributed tracing. We at New Relic, we do everything from instrument stuff at the browser, the mobile level, all the way through databases. So if you can imagine a customer who has a web application that's making a request to an API, you want to see the entire chain of events happen so that you can tell where the offending component is within the chain of events. Likewise, if something errors out here, you want to know that it's the thing that caused it. It's about like getting the right level of granularity so that you can continue drilling down into the particular thing you care about. In other words, connecting the component to the detail. And that detail comes in the form of a couple mechanisms. So specifically with like the Lambda execution environment, we think that the invocation source is a pretty important thing. This is the thing that triggers why the Lambda even exists in the first place. So when we're instrumenting, we not only pull the service that's driving the Lambda, the ARN, so that we can connect it back to the actual entity that is calling the Lambda, but we also pull the actual body of the request. So if you can imagine a situation where you have a stream processor and you have corrupted data because the publisher is no longer publishing like compliant JSON, that's going to be a problem that you need to go tell the publishing team to go address. It's not something you can fix with your Lambda itself. Likewise, right, understanding that the entire workload for a stream processor, really anything, is pretty critical for you to be able to actually troubleshoot the consequences. Other data we think is pretty important. Capturing tracebacks has proven to be pretty important here. This one's a little funny because if you look at like our instrumented traceback, you actually see a bunch of offending lines of Python that are from the Lambda libraries themselves, not even your code. But this, like any traceback, is going to tell you when you have unhandled exceptions or things you're not expecting. SDK operations. So this is potentially one of the most critical areas. So there are exceptions, but in serverless environments, it's pretty reliable that you'll have a few of your own custom components, but you'll use a lot of AWS managed components. So if you're using DynamoDB, an S3 in the context of a Lambda, it's pretty important that we instrument the level of detail that's required to get you to an answer quickly when something is going wrong there. So if your Dynamo request is getting throttled, your Lambda is probably not going to succeed. It's going to make the API request fail. The answer is not my Lambda is broken. The answer is my Dynamo request is getting throttled. Is it a provision capacity challenge? Is it a shared tenancy challenge, right? That level of detail basically lets us then connect them for context. So if you think about how these entities represent themselves, we know what's going on, we know where the problem's at, we need to now connect it so that we see the total effect on a workload. We know that the function is calling Dynamo and everything's behaving just fine, but it's publishing to a Kinesis stream that has capacity issues due to a load test. And we do this at New Relic because we instrument over 30 AWS services. We pull that data into the platform so that we can connect it with your APM instrumented applications or Lambda functions that are instrumented with New Relic. And that lets you do fun stuff like see the aggregate stuff that's happening across your AWS services and build custom dashboards that are pretty unique to that. So with that, I'm going to hand it over to Sean. He's going to go through some Capital One use cases, talk about their experience using Lambda.
Hey guys, quick intro on myself. I'm a software engineer for Capital One. Been there for about 2 years. This is my first reInvent, so it's been a really cool experience since Monday. I'm going to talk to you guys about our development experience around building a serverless application, kind of like the struggles we ran into, excuse me, and kind of the tools we use to alleviate those struggles. So I work on a team with about 3 full-time developers, and we're building a serverless application. The stack is an active passive stack, east and west, Route 53, CloudFront, S3, and we have our own internal API gateway that manages requests to 5 Lambdas in each region, but we actually have 6 total, so there's another Lambda in there doing some background tasks that we need for the app. Postgres, Snowflake, React, Node.js, and for a large part of our development over the past few years, we were relying on CloudWatch for monitoring, debugging, stuff like that, and we eventually integrated this New Relic tool that we're talking about today. Database setup is a read replica east-west, and to handle deployments, we have a custom CI/CD platform that was built in-house to kind of handle those compliance needs within a bank. So I'm sure we all can relate to this photo as developers. But quick question here, who is actively developing on a serverless application right now? Okay, so a good amount of you guys. So I'm sure you all will relate to everything I'm talking about today. So it introduces some new struggles and some familiar ones, mainly around debugging, reserved concurrency, working with timeouts, and how much memory do we really need, versioning, and handling deployments, and local development was a big issue for us. Like, how do we coordinate with devs developing on their machine and simulating like a local Lambda environment? So we have some good stories about that. We may not have enough time for them now, so I'd love to talk to you guys afterwards to fill you in there. Okay, so first, debugging. Most of you guys have looked through CloudWatch logs. They can become a bit cumbersome. CloudWatch does provide the right metrics, but in the beginning and even now, we wanted to see logs specific to application code at a very granular level. So like in our function code, there was a lot of standard out statements. We're using Winston to print out some logs to maybe make them look better. But again, you're still scrolling through CloudWatch to kind of look through and see what the error was. So that was a little bit of a struggle pain point for us. So you can only develop in the actual AWS console until you can't. In the beginning, that was nice. Easier to debug, right? But once your deployment package is too big, you're developing locally. So again, we had a need there for better tracebacks and cleaner logs. It's kind of the takeaway from that. So timeout versus memory and the trade-offs. When we first started, the timeouts were limited to 5 minutes or 300 seconds. They've since increased up to 15 minutes. So if your code is taking too long to execute, it could be that it doesn't have enough compute resources to execute the logic. So you could increase the memory and do some performance testing there, or it could be other services that your Lambdas depend on. Let's see. So we quickly discovered like the trade-off around timeouts and memories and the cost for operating each Lambda. So kind of the question there is, how can we experiment with this trade-off, and what tools can we use to get, the right answer to these questions? Some other issues: throttling and reserved concurrency. At some point in your development, I'm sure everyone here started seeing 429 errors. Even with a small user base, the application that we're working on started to see those early on. So if the function is invoked synchronously and is throttled, Lambda will return a 429 error, and then the invoking service is responsible for the retry. So this is a new, way that we have to handle this on the UI and the other services to account for that retry, something that we really didn't run into before on the UI side. So on reaching the concurrency limit associated with the function, any further invocation requests to the function are throttled, and the invocation doesn't execute your function. Also, if you're not keeping your Lambdas warm, there'll be latencies in your requests. So one thing we did, you'll see this later on, to alleviate that was create a CloudWatch rule that created a Lambda warming event, and it runs every 10 minutes to keep the Lambda going up for there. Also at the beginning, API Gateway had a hard limit of 500 requests per second per account. So going over that limit will also produce a 429 throttling response. And I think the button's not working. There we go. Okay. So versioning, this was another interesting kind of pain point in setting environment variables. If you version a Lambda, those variables, as you know, are locked into place. And if you want to change something like a security group, if it's in a VPC, you'll have to promote that Lambda again. So our strategy was creating an alias and incrementing the alias each deployment, and allowed the pipeline to handle that. So if we needed to change the security group, we'd run through the whole pipeline, through each environment, then that Lambda would get promoted, or that alias would get promoted. So local development, this was one of my favorite parts as a developer. Obviously you don't want to wait for a pipeline to run to see if your Lambda function is behaving properly or the way you intend it to do. So we were kind of searching for best ways to develop locally. We discovered a number of different options, mainly around the Node.js runtime. Some people are actually implementing express routes that are mapped to your event, so you can actually have an express server running locally and then see your events go to each route that way. But it may be too much, for what you're doing. So I don't think you would need to deploy express code just to do like a batch job or something similar. So there were some trade-offs there, and it left us wondering, how do we proceed? All right, so there's a whole discovery process around serverless development. The ecosystem is continuing to grow. More and more tools are coming out every day. Tools around CI/CD, local development, performance testing, and now New Relic monitoring for the Lambdas. So next we'll go through some of the tools that we actually used and set up to kind of help with our development. So again, CI/CD, as I mentioned, we have a custom pipeline that runs off of a collection of Jenkins and CloudFormation scripts, and we'll handle the versioning, any updates you need to configuration items like memory, timeout, reserve concurrency, handle all that through the pipeline. This was a nice feature to have. So we were using Docker images locally to send an event to our handler. So what it would do is run our code in a Docker container that mimics kind of the runtime environment inside of AWS. And you pass it events. Kind of a drawback there is you still have to pass like environment variables through the Docker command. So you may have a long string of password, database password, username, stuff like that. But it really helps kind of alleviate waiting for a pipeline to go and local development in general. Performance testing with Jmeter. It's kind of self-explanatory. We have our own internal gateway, so we would have to route requests through that from Jmeter to performance test our Lambdas. CloudWatch, as we discussed, digging through the logs was kind of a drawback, but we still utilize it. And then New Relic. Had some really good benefits with this new monitoring tool. Obviously, the dashboard is a huge plus. Creating custom events was a big help as a developer. So in your error handling logic, you can add New Relic custom events in there. And from the dashboard, you can start to get really good tracebacks to where problems are happening. So just a couple of follow-ups, findings. Keep your Lambdas warm with the CloudWatch rule. Use Docker images for local development. And the New Relic monitoring tool gave us better visibility into our logs and where errors were actually occurring. And with that, I'm going to pass it back to Andrew.
Cool. Thanks, Sean.
Sure.
So just to kind of wrap things up, what's next, right? So we kind of know what data we think is important. What's the answer? Sean explained that he clearly had some challenges using CloudWatch as a scalable solution in large, getting more complex architectures. So New Relic announced a private beta for a Lambda monitoring solution last week. We'll have more details on our blog on newrelic.com, but you can stop by our booth as well. We have a booth here in the Aria Quad as well as the Venetian. But generally speaking, I would say find your tools, gather the data, figure out how to synthesize it, understand what's meaningful to you. Not every piece of data is necessarily signal, so figure out what is to your business and your application, and then that'll make you more comfortable developing on serverless. With that, we'll take a bunch of questions. Thanks, guys. Yeah. So we've built instrumentation based on our traditional APM-based instrumentation that New Relic offers. So kind of some of the magic of New Relic, right, is that you can install our agent and you get data out of the box. So we've basically created I'll call it like Lambda mode for our agents. It uses a mechanism to essentially log data, which we then backhaul into the New Relic platform. You get a lot of the same depth that our traditional APM agents do, but a lot of more relevant data to Lambda execution specifically, so that you can actually find specific invocations or understand what the specific issue is that's causing a long-running Lambda or a failed invocation. So you basically, the blog entry has kind of all the details, but you say, hey, I'm interested, and then we'll send you an email saying, here's how you'll get involved. Yep.
What's the overhead?
Yeah, so that's a great question. So there are a couple of approaches to backhauling data, right? So traditionally, a lot of monitoring approaches have basically synchronously done it with a persistent application. Just you're sacrificing some of your network bandwidth for backhauling data to a third party. For obvious reasons, that's not a great model with Lambda, right? You don't want to, today, there's no mechanism to, after a successful invocation, like do some on shutdown activity that sweeps the data out. The one caveat to that is that CloudWatch does it for free underneath the hood. So our instrumentation adds really minimal overhead. New Relic's been around for quite some time, and our agent teams have a lot of experience building instrumentation without adding a ton of overhead. It's the marshalling, the gathering and marshalling of data that takes real time. So by decoupling that and using CloudWatch as the home for basically instrumented log data and then asynchronously sweeping that back to the New Relic platform, we add almost no overhead to the function itself. Yep. Yeah, it uses CloudWatch log streams. It's the log stream from CloudWatch logs to a Lambda function basically that gets deployed in your account.
Yeah, we basically provide the Lambda function, which you can find it today in the serverless application repository from AWS. It includes a SAM template and everything. So you basically deploy this Lambda in every region, and you can subscribe this Lambda to the log groups that you have. So what AWS will do for you is basically collect the batches of invocations that the instrumentation is writing in CloudWatch logs, and send all those batches into this Lambda that will collect the logs and send them back to New Relic.
Yes? Yeah, so a lot of the same features that you're used to using on the New Relic platform are completely available in the Lambda context as well. Alerts based on data points like events are totally there because we're generating events for each of the invocations. In fact, we're generating a lot of events. If your invocation talks to Dynamo, and then does something else, you'll see multiple events representing each of those segments of the invocation.
What was the question?
Specifically alerts.
So every capability from New Relic on alerting, like baseline alert, query-based alerting, all that.
And then he was asking where you would configure it.
Where you can?
Where you would configure it.
In the alert section, just in the same way. So alert is a platform capability at New Relic. So regardless of the product you're using, you will use the same alert system. So we have like 6 products at New Relic and a single alerting product across the 6 of them. So you can basically write the same alert for browser performance, mobile performance, like backend services performance applications, serverless applications, and infrastructure.
Yep.
For the use case of a REST API built on API gateway and Lambda,
Yep.
does New Relic offer the solution to track what's happening at the network level? Let's say to detect something like a TCP handshake failure or congestion network inside the AWS network?
Yeah, so our Lambda monitoring solution is very focused on your application code. It's less focused on network level stuff. So New Relic infrastructure historically has monitored a lot of the kind of like underlying components of the infrastructure that does that. I think it's a lot less applicable in the Lambda context, but I think it's worth looking at it. One of the interesting things is that the Lambda execution environment is probably one of the first places that's like a true hybridized environment between like carrying a lot of the core infrastructure data into the context of the actual application like execution itself. So I think we're still learning a lot of things about what the right payload of data is and what we have access to understand what's happening. Any more questions? Yep.
On the
Yeah, the biggest benefit that I had was with the tracebacks and getting like custom events sent to a dashboard. Does that answer your question? Sure. So say you're querying Postgres and there's an error. And inside of that if block where if there's an error, you can put a new Relic custom event with a key by your own name, whatever you want to say. So say it's like a Lambda that updates a car database, right? You could say car update and then send in that error object. And then you can see it in the console and get tracebacks too on other services. So if it was like Postgres within AWS, you could see that there was a Postgres error. Or if you're using some SDK, right, like KMS encryption or any other resource available from the SDK, you can see that as well.
So for the standard throughput and error monitoring, Serverless is sufficient? Like without the custom events?
For the standard throughput?
Yeah, just the API throughput, error counters.
Yeah.
So I used New Relic years back at a previous company on web requests, like an ASP.NET site, and I remember all the aggregated data got sent up once a minute, but we only got the one slowest transaction each minute details on that. Is that still the case? And for Lambda, do you follow a similar pattern there where you're sampling and only sending like a few interesting ones or the slowest ones for the details, but you get the aggregated summary stuff? How are you handling that?
Yeah, so I'll talk specifically about the Lambda use case, and then I'll let Alberto kind of talk about the larger APM context. So in the Lambda use case, today we actually are backhauling all of the data to the New Relic platform. That's probably not super sustainable long term. Sampling was created so that it gave you kind of a good indicator, a good representative set of data that told you what was generally going on, and then you could dive deeper. I think what we want to avoid is customers then having to use another tool or another data source to then figure out what's actually going on. The approach that we've taken actually has a ton of power where we've kind of durably stored like every actual invocation. So we know for a particular request ID what services got talked to, what code got executed. If we grabbed a stack trace, it's there. And if we didn't sample it because of some criteria, there's a potential that down the road we could then pull it back into the platform so that you have the ability to visualize it. And I think that that's kind of how we're thinking about it, right? Which is that we want to give you as much data as we think is relevant in real time while remaining economical and realistic so that you're not paying massive data transfer bills or seeing lots of extraneous data. But at the same time, if you want to find that particular request ID that is important to you to understand what actually happened in this one instance, that you have a mechanism to do so. I think more broadly around APM, there's a lot of evolution happening around harvest cycles, and we're happy to chat with you about that offline at the booth if you have additional questions there. Do you have anything else to add?
No, I think, we can check it offline if you want. Yeah.
All right. Any more? Not? Everyone enjoy the pub crawl. Thank you.
Thank you, guys. Thank you.